Okay, so let's talk a minute. Guys, permutation. I have 4 people. I need to send them down as, let's do 3 people, makes life easier. I need to send them down as a president and a vice president. I need a pres, I need a vice pres. How can I send them down? Give me a combination here. Give me a way to send them down. AB, AC, BC, BA, CB, CA. I just couldn't fit it underneath there. So how many ways do I have that I can send them down? 6 ways. So it makes sense. I need 2 things. I start with 3 choices. Then I have 2. I have 6 different ways to make a vice president and a president. Now I change my mind. I say, well, we really don't need a vice president and president. We just need this committee. We just need a committee of 2. From, oops, that's 2 rounds there. From these 3 people. I just need a committee. What's a committee? What would be in my committee? 2. So give me 2 letters. AB, AC, and BC. What about CB? That just be repeating. Good, because BC and CB are the same thing, right? They're the same committee. It doesn't matter who goes first. So what happens when order does not matter, I can't have those same groups again. It matters here because CA and AC are totally different. But look, I only took an AB, an AC, a BC. I only took like half of those. So we said combinations of 3 things 2 at a time. It goes down to 3 times 2. And then I'm going to divide by, if I subtract this, if I take this, well, take this factorial, you don't really need a factorial, but if I divide this by this factorial, this would work. So I say 6 divided by 2 gives me 3. And you can absolutely put it in your calculator. We'll talk about it a little bit more. But I'm going to get less committees than I'm going to get when order mattered, right? Because I got duplicates out there. So today we're going to talk combinations. These are combinations. Good words for combinations that you're going to see are committees, are groups, teams, sets. Sometimes they use the word sets. Anything that doesn't have an order to it. These are things that we use for combinations. Lineups on a baseball team is a permutation. The baseball team itself is a combination. But if I want the batting lineup, I need a permutation. If I want my defensive group versus my offensive group, that's a combination. It doesn't matter what order I put them in when I put them out there. Yes, they're designated positions, but it doesn't matter who I call out there first. Okay? So these are things we're going to look at today. Permutations versus combinations. And again, I don't write their way to do it. So they say this. They say 3 things 2 at a time. Take n factorial. They do theirs a little different than mine. They take n factorial, which is your 3, over 3 minus 2, 1 factorial times r factorial, 2 factorial. So it says 3 times 2 times 1 over 1 times 2 times 1. And when they reduce this, it comes out to be the same thing. So again, if you're going to work them out the long way, don't do their way, do my way. My way is take this do the 3 times 2 over the last factorial, and that'll get you out of that. So let's see what's going on here. A State Department of Transportation plans to develop a new section of interstate highway and receives 16 bids for the project. The state plans to hire 4 of the bidding companies. How many different combinations? Now they ask combinations. And they use the word different. A lot of times we see different ways, but there's still different combinations. Different combinations of 4 companies. Here's your key numbers. 4 out of how many? 16. These are our important numbers. So combinations, this is how you start. C. How many do you have to choose from? 16. How many do you want? 4. Okay, put it in your calc. So you can do it this way. 16, 4 down, times 15, times 14, times 13, over 4 factorial. 4 times 3 times 2 times 1. That'll give you the same answer as your calculator will. Your calculator says, calculator is the easiest way to go. You've got to put the 16 in first. Then you're going to go to math. You're going to go to probability. You come down to the C this time and put in 4. So we get 1820 different ways. 1,820. God bless you. If you do it out the long way, it's 16 times 15 times 14 times 13. This gives us 43,680 over 1224, divide by 24, and you'll get the same answer. Don't use their format, use mine if you're going to do it out the long way.
So like on tests or something, do we have to show that work? Or we
nope,
just do it
I want you to use your calculator. But if you're going to think, it's like sometimes you can think combinations in your head when they're small. If you think of 10 things taken 2 at a time, you have to put it in your calc, right?
Yeah.
But instead in your head you can say 10, come down two spaces, 10 times 9, and divide it by 2. If I take half of 10, that's 5. My answer is 45. I really don't need to look at my calculator. Yeah, if you want to think that way, but you can always pick up your calculator. You have your calculator there to do it. But I kind of want you to, by the time we get to dividing out by this R, it kind of makes sense. Those are the duplicates you're taking out. Their formula is kind of weird, but they do 16 factorial over 12 factorial times 4 factorial. Like they subtract the first and then they do it this way. So 16, the 12 cancels out part of your 16, right? From 12 on. So if I did 16, 15, 14, 13, 12, da, 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 da. This 12 cancels out this. So isn't it left with the same that I do? It's left with the exact same. For some odd reason, they just take the long way around. I don't know why. Okay, so the manager of an accounting department wants to form a 3-person advisory team, an advisory committee from 20 employees. I have 20 employees. How many ways can this manager form this committee? Does it matter what order they sit on this committee?
No.
Therefore, is it a C or a P? C. When order doesn't matter, you start with a C. How many do you have to choose from? 20. How many do you want? 3. And put it in your calculator. So it would say 20 times 19 times 18 over 3 times 2 times 1. Back in my day, when we didn't have calculators, we had to say take a 6 out of here, and we had to multiply all these things. But you guys have calculators. It's not so bad for you guys. And this one would be 1140. Still a lot of committee, isn't it? So that manager has to think really hard from his 20 employees how he's going to come up with a 3-person advisory committee. It's a lot of different ways to come up with. Make sense? Okay. A student advisory board consists of 17 members. This is important. This is a number we need. 3 members, 3, and sometimes you got to find those numbers, serve as the board's chair, the board's secretary, the board's webmaster. Each member is equally likely to serve in any of the positions. What is the probability of selecting at random the 3 members who currently hold these 3 positions? So, what are they asking for? They're asking for what word? They're asking for a probability. It's in the probability part over whole. Okay, so I need to find the probability each member is equally likely to serve. Permutations in here, I'm sorry. Okay, that's because now we're going to be doing probabilities. Probabilities are a little different than when you find how many different ways. So you've got to find your ways first. Now, does it matter what position you put these in? To be chair, secretary, and webmaster? So does order matter? Order is going to matter here because of these. This is how you're going to ask yourself this. I need special positions. So order matters. So I'm automatically a P. How many do I have to choose from? 17. How many do I want? 3. It's the same as if you laid out your 3 lines and said 17 times 16 times 15. So in your calculator, you're going to lay this out. And this is going to become going to become 4,080 different ways that I can set up a chair, a secretary, a webmaster.
Say all 3 positions were the same one, then it would be a combination, wouldn't it?
If it was a committee of these 3 people, then it would be a combination. But because I want to be chair, not secretary, it matters that I'm chair and you're secretary.
And just say you were like, 3 secretaries, then it would be a combination?
Then it would be a combination. If it's 3 the same. Usually they will say a committee.
Okay.
Or a group, a team, something like that.
Okay.
And then you would know, see. So the first thing we're going to decide is that. Is it a P? Is it a C? Right. Now, is this my answer to my probability? Is the probability greater than 1? How many correct ways did this board happen? Apparently these were already currently holding these positions. So I've got John as chair. I have Kevin as secretary. And I have Devin as webmaster. How many ways does this happen? 1 way. So my probability is part over whole. This is the answer to this question. First you got to find how many ways, then you got to set up your probability. In this case, there's only 1 way to find those 3 guys, those 3 people, those 3 positions. So 1 over this, you can leave it like this, or you can convert it to decimals. Now normally we say 3 decimals. However, if I put 3 decimals, my answer looks like a 0. And 0 means it could never happen. But don't I have a committee?
Yes.
So we go out to the first significant digit. Make sure you go out to the first significant digit. Kind of like we did with your combination, with your other things there. Whenever you round. So when you recognize this, first thing we're going to ask is, does order matter? If order matters, I'm a P. If order doesn't matter, I'm a C. We're going to figure out the weights. Then we're going to look back to what they asked us. Did they ask us how many different ways can I make this 3 group? Or did they ask us what is the probability of something happening? If it's probability, I got to build my probability. I can't have a probability greater than 1. Does that make sense? It's a little tricky. Okay, let's try another one. A student advisory board consists of 20 members. 2 members, and sometimes it helps if you write the number 2, serves as a board's chair and the secretary. Each member is equally likely to serve. They say that because that's the randomization. What is the probability of selecting at random the 2 members who currently hold these 2 positions? So ask yourself first, does order matter? Yes? I'm getting a yes. Because we have a chair and we have a secretary. Right? So if order matters, is it a P or a C, Stephen? It's a P. Good. How many do you have to choose from? 20. How many do you want? 2. So this is 20 times 19. So it's probably 3,800, right? Is that a probability? How many ways do I have the exact pair? Tori's president, Harande's Tori's chair, Harande's secretary. How many ways is that going to happen? 1. So my probability is 1 over this. Sachin?
No, it's 380.
It's 3 what? 80? Thank you. I was a little off, huh? Close, no bananas. 20 times 20 is 4,000 minus 19, so am I even close there? It's 380. Oh, 380. 380. Thank you. So 1 over 380.
It's saying that 2 members holding those 2 positions, but could those 2 people switch positions, or do they have to?
Well, the ones that are currently holding them?
Yes.
Currently, Tori's chair, Harande's.
So I'm saying, can they flip flop?
No, because their order matters. Tori says, I don't want to be secretary, I'm only chair. Yeah, I don't want to be secretary either. Harande's stuck with being secretary. So when order matters, that's what you get. Do we see the difference of probabilities versus how many ways? You've always got to find the how many ways first. All right, let's try another one. I love doing probabilities. Find the probability, part over whole, of being dealt 5 diamonds from a standard deck of 52 cards. So, if I need to hold 5 diamonds in my hands, right? I need 5 diamonds. First time through, what is the probability of getting a diamond?
2.
I choose 52 cards, but how many of them are diamonds? 13. Now I'm holding that diamond. You just dealt me a diamond. How many diamonds are left? 12 out of, then 11 out of, then 10 out of, and 9 out of. What do I do to all those guys? I multiply them. Okay, and you can do it this way. It becomes very small. Is this called this flush? Is this a flush when they're all the same suit? Yes. Flush. This is when they're all the same suit. Now, we can also do this as a combination. Because does it matter what order I actually hold those cards in? No. So, how many, I gotta do part over hold. I want 5 diamonds. Out of how many diamonds that are dealt? How many diamonds in my deck? And I want 5 of those. So that'll give me how many different ways can I choose 5 diamonds. Does it matter what order I hold those diamonds in? Unless I want it straight flush, but all I want is 5 diamonds. Out of, probability is part of a whole. Out of, we call this denominator the generic denominator. I call it a generic denominator. I don't care about my diamonds. How many cards do I have in my whole deck? 52. So what is the probability out of dealing me 5 cards out of 52 that 5 of them are diamonds? So again, part over whole. I could do it that way, reduce my probabilities, or I can do it this way. This is a nice way to look at it. And the bottom number is always the generic number. Whether I want diamonds, I want hearts, I want all reds. The bottom is my generic number, any 5 cards. The top is the specific part of it. Give me 5 diamonds. And I don't care what order my diamonds sit in. So any order, you're still going to get the same answer. We can do this a couple of different ways. The book goes this way. I'm pretty sure your book goes this way. Yeah, your book goes with the combinations. You can do it this way, but since they're doing combinations, they like to go that way. I like that way too. Okay? I'm going to have you guys try the next one and try to set it up as a combination. It's kind of the same. They just did a little something extra. They included 2 jokers in their cards. So instead of 52 cards, you have 54 cards. And those are wild cards. Does anybody know what wild cards mean? They could what? You can use it for anything. So if you're going to be looking for diamonds, what would you want to use it as? My 2 jokers now, if I need to be dealt 5 diamonds, what would I want to use those 2 jokers as? Diamonds. So you have 54 cards, and how many of them are diamonds possible? 15, right? So see if you can set me up a combination. Anybody come up with an answer? So how am I going to set this up? I have combinations. How many cards do I have to choose from for my diamonds? 15. How many do I want? I still want 5. It normally was 13, but because we can use the jokers, why have the jokers in there if you're not going to use them for diamonds, right? Now, it goes over, probability is always part over whole. It goes over my denominator, which is any 5 cards. But how many are in my deck now? 54. It still could work like this. I can still do this. I have 15 out of 54 times 14 out of 53 times 13 out of 52 times 12 out of 51 times 11 out of 50. Do You can still do it this way because that does work, or you can set it up as combinations, which I think that's what they were looking for. So you should get that. Now your calculator, did it give you an E?
Yeah.
So what'd you get? 9 point?
9.4
Times 10 to the negative 4. This is e to the negative 4, is what your calculator says. It's a scientific notation number. It should tell you right away your probability can't be greater than 1. So keep looking. There's an e there. It says move the decimal place 4 positions to the left. So if you move it 4 positions, you're giving it 3 zeros. Watch that e. What gives it away is your probability cannot be greater than 1. Okay, let's try another one. A food manufacturer is analyzing a sample of 400 corn kernels for the presence of a toxin. In this sample, 3 kernels have dangerously high level of toxins. So we got 3 toxic kernels out of 400. So out of 400, 3 are toxic. How many are not toxic? 397 are not toxic. We'll just say good. They're good, or non-toxic. What is the, 4 kernels are chosen at random. I want to pick 4. What is the probability out of the 4 that I pick that exactly 1 kernel contains a high level of toxin? I want one to be toxic, and I want the other 3 not to be toxic, is what I want. So when I look at my probability, I say 1 toxic, 3 good. That's how we're going to start. This is what you want to pick. And probability is always part over whole. So how many kernels am I picking from? 400. Does it matter what order I pick these things in? So these are combinations. So I'm going to pick from my 400, I want to pick 4 kernels. This is a good way to start. Lay out all the parts that you have. We've decided that order does not matter. These are the steps I would go through. So therefore, I'm using a combination. And because I'm a probability, I've got to have a combination over a combination. So let's hit the denominator first. How many kernels do you have to choose from? How many do you want? You want 1 to be toxic, 1 toxic. How many toxics do you have to choose from? 3, and you want 1 of them. But then you want 3 that are good. How many good ones do you have to choose from? 397. How many of those do you want? Ooh, 3. 3 goods. So there's your probabilities. A little different because you have a combination of things to happen. You want 1 that's toxic and the rest that are not. So you can put it in your calculator, and this one will work even without parentheses because order of operations, that it'll do your multiply and then it'll do your divide. It's just annoying with the C's. You have to keep going back and forth with your C's. This should come out to be 0.030. Okay, so do you see what we did here? We had to kind of separate this a little bit. Because we wanted not just 3 toxics, not 4 toxics. What is the probability of getting 4 toxics? Does it matter what order I get them in? No, so I got a combination. I got a C over C, start like that. Oh, why not? There's only 3 toxics. Good. So if I would set it up like this with a 4, I would say, whoops, I only have 3. I can't do this. I can't take 4 out of 3, right? So therefore, what is my probability? 0. This is the impossible case. Okay, good. Chris thought before we did it. But if you didn't see it, when you get here, this number on the right can never be greater than the number on the left. You can't take 4 out of 3. You can take 3 out of 4, but not the other way. Okay? All right. And this is a very good one. We're going to work with this one for a little bit. A jury consists of 5 men and 7 women. So they gave me this for a reason. So how many people are actually sitting on my jury? 12 people on my jury. Always do this. I want to select 3 at random. Does order matter? What way I select them in from a jury? No, well, as long as they're men, I'm okay. So order doesn't matter. I'm a combinations. I want to find the probability that I get 3 men. This is the easiest way to start, because otherwise you look at it and you say, all right, what do I do now? So work one step at a time. Lay out the numbers. Lay out, is it permutation, is it combination? If it's a probability, you got part over whole. So therefore, I'm going to go C over C. The bottom number is your whole. That's your generic. How many people do I have to choose from? All together. How many do I want? 3. Well, out of those, any 3 people, I want them to be men. How many men do I have to choose from? 5. It's that simple. Plug that into your calculator. Are we seeing this? Okay, I'm going to change this up a little bit. What is the probability that I choose 2 men, 1 woman? Probability that I choose 2 men, 1 woman. Does it matter what order I choose them in? So am I combinations or permutations? Combinations. I am a probability. So probability tells me part over whole. So I'm going to start like this. C over C. Generic. My bottom number. Any 3. How many do I have to choose from? 12. I want any 3. That's my bottom number. My generic. My whole. My total. Combinations. I wanted to say 2 men, 1 woman. How many men do I have to choose from? 5. How many do I want? 2 times, how many women do I have to choose from? 7. How many do I want? 1. And then I just multiply. What'd you get, Tori? Did you do this one? What'd you get? 7 over 22? And to get a decimal by any chance? I didn't work this one out. Point 2318. Okay, good. So are we kind of seeing these combinations? Combinations, and any of them that you do, the first thing you want to do is decide, does order matter? If order matters, start with the P on your paper. If order doesn't matter, start with the C. Look at the numbers they give you. Why did they tell me 5 men, 7 women? What do they add up to? How many do I want? That's what's going to be on the right side of my thing. What is it I'm looking for? Lay it out like this. I want to see probability of 3 men, 2 men, 1 woman. And that's how you're going to set right underneath it. How many men? 5. I want 2. How many women? 7. I want 1. Over your total probability. Don't forget your total generic. I call it the generic, the any 3. Make sense? Yes. I've been lucky because they've been calling such very few numbers. It's very low. But I don't want to jinx myself. Okay. I'm going to help you out. I'll tell you why in a minute here. They look like a lot, but a lot of them are not a lot of work. It does, but it's not a lot of work. Okay, so the numbers that I circled, the circled numbers are permutations. So all the numbers that I circled are permutations, just to help you out. In case I'm not here tomorrow and you can't ask me, the circled ones are permutations. And even though I circled them, look into why they are permutations, okay? Alright, so you have tomorrow to